All right, guys, so we're going to start with section 6.1 here, estimating with finite sums. This is definitely something I think you guys can handle without me, so me being gone and the point we're at is kind of some good timing. So we're going to look at this problem first, and this is a problem that obviously I think you all could figure out without using calculus, but we're going to use kind of what we know about solving this problem algebraically and graphically to talk about how it's tied to calculus. Okay, so we're going to pretend that I'm driving in my car and I was traveling at a rate of 65 miles per hour for 5 hours. And you're going to find how far I traveled. Okay, so the first thing I'm going to have us do is I'm going to sketch a graph of this. Feel free to pause this video as you need to. I know some of you guys like to write these sort of things in your notes. Okay, so here's my graph, here's my velocity on my y-axis. Here is my time, and that's in hours, and my velocity is in miles per hour. Okay, so graphically, if I look at this, we'll say that right here is 65 miles per hour. We go 1, 2, 3, 4, 5, 6 hours. Okay, so even before I drew this, oops, sorry, 5 hours is what we went. Let me erase that. So even before I drew this out, I know what many of you are thinking. Many of you are thinking, well, you traveled 65 times 5 hours is 325 miles. So right away you're like, you, Ms. Jorgensen, we're not stupid. You drove 325 miles, which is correct. I did. Okay, but we want to look at that graphically here. So if I look at that graphically here, I want you guys to think about where's that 325 represented on this graph? When we talked about a position, I'm going to draw it down here, I think, and then I'll move this back up. When I talked about a position versus time graph, okay, when I talked about traveling somewhere, the rate, okay, or in this case what we're talking about is miles per hour, is represented by the slope of the line. Okay, so this slope was my rate. Okay, if we call this miles and we call this hours. All right, that was my rate, which is obviously a really important word in calculus, right? The rate is a slope, which is a derivative. Okay, very important calculus concept. So this is the other really important calculus concept. All right, when we're looking at this, is 325. This is 65. This distance is 5. So what we're really looking at is the area under the curve. Okay, so that is the next really important concept in calculus, the area under the curve. So the area under the curve represents a total given a rate. Okay, so we were given this rate, we knew this rate, we knew how long that rate happened for, and we could find the total by using the area under the curve. Okay, so the area under the curve represents some sort of total. Okay, so this is obviously a really basic example of what we're going to be looking at. We're going to be looking at some other types of problems. So if we think about a particle moving, because we like to talk about particles moving a lot in calculus, right? So a particle, this is going to be another example. A particle moves along a line such that v of t equals, let's say, negative 2t plus 8. How far did the particle travel in the first 3 seconds? V of t is in centimeters per second. Okay? So obviously we need to know those units so that we can appropriately label things. Okay? So I'm going to draw a graph of velocity. I'm going to draw my velocity graph here. So I've got velocity versus time. And this is pretty easy, right? I've got a linear velocity function. Sorry, I got to try to get this a little bit higher up maybe. I've got this linear velocity function, negative 2t plus 8. And so 8 is my y-intercept. So I'm going to put 8 up here. And it's going to hit my x-intercept at 4. So maybe I'm going to put 4 here. Here's 3 seconds. At 3 seconds, if I plug 3 in here, it's going to be at 2. Okay. So this is kind of my line, my velocity. And I'm really just looking at this part. Okay, that part of my underneath the curve of my velocity. All right, so we want to figure out how far they traveled. So we want to figure out that area under the curve. Okay, the distance traveled, so total distance traveled is equal to the area under the rate. I'm just going to call it the rate curve. Okay, because we're going to be talking about some things that aren't necessarily distance and velocity, but maybe how fast oil is leaking out of a tank, and so we want to figure out how much oil spilled out, or how fast I can fill a water tower, so that I want to know how much total water's in there. So just we're using some velocity examples here. I think they make a little more sense for students, especially if you've had physics or in physics now. So that's why we're using these. But really it could be any rate curve. Okay, that's really important. It's total distance or a total area is under the rate curve. So we got to figure out how much is under here. Couple ways you can do it. This shape is a trapezoid. Okay, so if I turn the paper, I'll turn it back here, sorry. But if I turn the paper, it looks more like a trapezoid this way. I've got base 1, base 2, and my height. Okay, so if you remember how to find the area of a trapezoid, that will benefit you. And actually, you're going to have to learn that because there is something called the trapezoid rule that we're going to talk about. Not today. So eventually, you're going to have to know the area of a trapezoid. But for now, I think probably what people are most comfortable with is like splitting this up into 2 pieces. So you've got this rectangle. Okay, so this rectangle is a height of 2 and a base of 3. So 2 times 3, which is 6. And then we have a triangle. Okay, which is, it looks like 2, 4, 6 high. So 1/2 times 6 times, and it's 3 across the base. So that's going to be 6 also. That was convenient. So my total is going to be 12 centimeters. Okay, if you do remember how to write the area of a trapezoid is 1/2 times base 1 plus base 2 times your height. So that area is going to be 1/2 times, my base 1 is this whole thing, so 8 plus my base 2 is this part, which is 2 times this is actually my height, so 3. So that gives me 1/2 times oh, I did my base 1 and base 2 wrong. My apologies. I think I'm looking at this wrong. 8. What did I mess up? Oh, this is 9. Sorry about that. can't do arithmetic correctly. You guys know that. So that gives me 15. It's just like I'm in the classroom right now, right? Sometimes I make mistakes. And then this is going to be 10 times 3, which is going to give us 15 centimeters as well. So it shouldn't really matter how you find that. So however you want to do that is acceptable. Okay? So that is going to be what you are going to work on tonight. I'm going to give you some problems where it's probably going to help you to make a sketch of the curve and look at